As mentioned, my name is Hugh Petersen. I am the product manager at Standard Imaging for the DoseView 3D Phantom. And we like to think of ourselves as a hardware manufacturer and a software manufacturer. We've been in business of doing QA equipment for quite some time. And with the development of our water phantom, we've taken pains to make sure that we produce better hardware to get that better data, and I think you'll see that that our system does just that. I think my PowerPoint should be moving. There we go. So, this is just a few of the reasons why we come to work each day. Number of coworkers shown on the screen here. And we know on a daily basis that cancer affects families, coworkers, friends in any number of ways, both directly and indirectly. And we at Standard Imaging, we're very proud to be a leading manufacturer of QA equipment and instruments for radiation therapy. And we want to be partnering in your precision as well. So we hope to be there for you as you need to improve QA equipment throughout the now and the future. Just a little bit of housekeeping to start. We will record this session, and then any of the attendees or anybody who has registered will be sent a link for the recording, so you can watch it again or share it with colleagues, what have you. There you are on mute just to avoid any talkover and what have you. So any questions that you might have at any time, please. There's a chat box or a question box in the control panel that you can enter your questions in, and I can answer those afterwards. But just a quick bit of history again. We were founded in 1989, and you probably are all very familiar with our well chamber, which was our first product to come to market, and still very much in use today. And we've improved upon it and built new source holders as new sources came online. So it's something that people are very familiar with. And through those years, we've added quite a few QA equipment. Obviously, our X-ray and line of ion chambers, our electrometers, various softwares like I am sure for secondary MU calculation, our PIPS Pro QA software for TG142, our Adaptivo patient-specific QA software, et cetera. So we've done a lot of development over the years, added new products, and really became a complete integrated solution for QA for the radiation oncology facilities out there. But today I want to talk about the DoseView 3D Water Phantom, and what I want to do today is just give you an overview. I invite anybody who wants to take a deeper dive and a more informed look at it, a little more detailed look at it, to contact your regional representative or distributor, and we can set up with you a direct webinar one-on-one with you and your group to answer more specific questions and more details. But today I just want to give you an overview of the system, both the hardware and the software. So basically, there's a number of objectives for a water phantom. Of course, you got your acceptance testing, where you're testing your LINAC versus the manufacturer's stated specs. There's the commissioning of the LINACs as well, where you're checking all your energies, your field sizes, your wedges, etc. So that's obviously a big objective as well. Then there's your annual tests, your TG142 tests, and also should anything change, you want to do those periodic checks of beam quality as needed. And one thing with the DoseView Water Phantom is, we want to make it something that's simple enough to use. Best case scenario, you only use it once a year, and you want to be able to pull it out of storage and be comfortable with it right away. And that's one thing that we've always prided ourselves on with the DoseView, both the hardware and the software, is it's uncomplex, non-complex functionality. We want to give you all the tools you need, but make it easy and friendly to use. So what makes a good water phantom? Obviously, you want something that's highly repeatable and very accurate. And we hit on both those points, and I'll kind of get in that a little bit as well. You want obviously to produce the high quality raw measurements. You don't want to have to do a lot of post-scan processing. You want to be able to, for some reason I'm delaying here. You want reliable hardware year after year. So you want to be able to again, like I said, pull it out of storage on those infrequent uses and have it there and operational, both the hardware and the software. You want it to be easy to set up, since again it may only be used on that annual basis, best case scenario. And of course, you want flexibility and compatibility. And with our electrometer and software and hardware components on the DoseView, you've got the ability to use just about any detector on the market. We interface with a number of different protocols for data analysis. We export to a number of treatment planning formats. So we have a very versatile system and compatible with just about any need out there. But let's get into the hardware a little bit. So obviously I mentioned accurate and consistent positioning. The hardware itself, that we have a new generation of hardware. We redesigned the system to give us a little bit more rigidity and better reproducibility than even our Generation 1 hardware, which was very, very good and very reproducible on its own. But we've used extruded aluminum frame, which gives you much better rigidity. It simplifies the setup and it maintains the reproducibility. We have accuracy and repeatability within 0.1 millimeter per axis. It allows for quick and precise 3-point leveling. And each individual system before it goes out the door is measured for accuracy on an industrial coordinate measurement unit that we have in house, just to verify that accuracy and performance. That when it lands on your in your department, that you can be assured that it will perform as it's expected. A few other tools we have: the water tank and frame are mechanically secured together, which ensures a long-term integrity. It has a fully integrated lift and reservoir cart with a precision positioning platform. And we do also, if you don't want the reservoir cart, we have just a mechanical lift cart available as well. And just small details we incorporate into the system. This is only one of many, but we actually have a suction drain system that has a moat that actually will help pull the vast majority of the water out of the tank. So none of the mechanics are sitting in water after you drain the tank. There's minimal water in the bottom of the tank you have to dry out or clean out after scanning. So it's little things like that kind of really make it an advanced system. As I mentioned, we have a positioning platform for the water phantom. This is incorporated into the lift cart, and you can see there are on the rotational adjustments, there are points at 45 and 90 degrees that lock into place. So if you want to do rotate the tank and do diagonal scans, you can do that very easily and lock it into place accurately. Also on the corners, you can see there are some levers here. These are fine adjustment levers to rotate, to be able to move it in the X and Y direction very, very finely. And then the one on the corner is for rotational. So you can get those setups very easily, very quickly. The new generation of hardware, we've lowered the profile a bit. We've compacted the system just a little bit, which not only improves the rigidity as far as the way we're making the frame system now, but it also is now Halcyon compatible. It fits in the Halcyon bore and allows you to do QA and commissioning on the Halcyon system. And there's just a couple more touches on the Halcyon unit as well. We, like I mentioned, the lower profile and the compact design allows you to fit in the Halcyon, which you can see in the middle photo here. On the right photo, we have added lines to the side of the tank for the internal lasers, and then there's also a Halcyon fill line, which is about 10 centimeters above that, because obviously there's with the couch limitation, you don't have the weight capabilities of the lift cart. You have a limited weight on the couch, so we fall within that with that new fill line for the Halcyon. And additionally, on the left, you can see we have available for Halcyon users and a brass alignment cap, which you can utilize the cap for positioning the chamber within the Halcyon, utilizing the MV imaging system. That's something obviously that was a challenge or is a challenge in aligning the chambers, because you don't have the ability to eyeball the position or use your field lights like you do on a conventional C-arm Linac. So we put together and are building this brass build-up cap for alignment for the MV imaging system. We have wireless connectivity. We have a wireless pendant. The wireless pendant has a great deal of functionality on it. It's very aids in the simple setup and system configuration, allowing you to freely walk around the system as you're eyeballing the chamber for the water level and positioning like that. It has an onboard display that always shows your X, Y, and Z positions of the probe. Has 3 touch button speed. Here you can set it up for fast, slow, and individual step, and those steps are 0.1 millimeter steps. So a very fine, precise movement of the system. Nice thing too is it has a disable bias button on the pendant as well. We had a colleague who is a clinical physicist, and that's one of the things that he always liked about this system. One of the things I should say, but one of the things he really liked about the system was to disable the bias. He couldn't tell us how many times he'd walk into the vault after being at the console, setting things up, turning on the bias at the electrometer, or at the software, I should say, and walking back in to make an adjustment, only to realize that he left the bias on. So you can adjust that on and off at the pendant as well in the vault. We also, for the system itself, include a wired or wireless connectivity to the PC. We use a Zigbee type radio functionality for a wireless connectivity. Again, gives you that versatility and convenience. You don't have all these cables running from the conduit to the system, or across the floor. You can do it wirelessly. Or you can also, if preferred, do it wired as well with a included cabling system that we provide with the system. One of the things, as I mentioned early on, is we've had a long history with building reference class electrometers, and we've taken that experience and that expertise and incorporated into our electrometer for our DoseView system. It's a charge digitizing electrometer for high-speed acquisition. It has a 10 femtocoulomb resolution. You have the ability to set it for dual polarity, so plus or minus voltage. And then you can also have independent bias voltage, so you can turn on and off the field or the reference. You don't have to have them both on or both off. They are independent. Another time-saving feature that we offer that gets you scanning fairly quickly is our versatile detector alignment system. It has the water alignment jig, as you can see here, and then there's also a detector alignment jig here. But the water surface alignment jig basically gives you the ability to visualize a correct alignment and correct leveling of the system very easily as you do your runouts to watch basically you can see the X when it's at the water surface. If it's above or below, it distorts, and you can see that very easily and adjust that accordingly and get your leveling and your runouts correct very easily. Typically, it takes about 15 minutes to do this. And one of the things that we've looked at, obviously, I know that some of our competitors have what they consider automatic alignment or automated leveling. Typically, we've kind of looked into that. We've played around with some functionalities there, and we still, go to the old tried and true, because even with the automatic leveling, you set it, you still need to eyeball it and then make sure it's correct. And if it's not, you have to run through the whole process again. There's not really any fine tuning with that. With ours, you can kind of fine tune it. And quite honestly, we've got a user at the calibration lab in Wisconsin that uses our at the University of Wisconsin uses our scanning system, and he typically can get it aligned and leveled in about 10 minutes. So it's a very fast leveling and setup with our alignment jig. And the nice thing too with the water surface alignment jig, setting up the ion chamber within the block here allows you to basically lift this water jig out, replace it with the chamber as it's already in place and precisely aligned, and it's just an even swap out, very quick swap out, puts that chamber in the exact spot that you want it very quickly. We also have an automatic find beam center. Basically, you turn the beam on, click find the beam center. It will run to the in-plane and cross-plane edges of the field in both directions, and it will find that field edge and give you any required shifts to be centered in that beam. And just gives you a little bit of an idea of what you're looking at here with that. Also includes two of our X-ray and A28 0.125 volume scanning chambers, and they're homogeneous Schanke plastic. So the collector, guard, and shell are all this plastic, conductive plastic material. So there's no perturbation. They're very low Z material as opposed to a chamber that's graphite based and has a metal collector. We also have proven X-ray quality. We're very confident in our ion chambers, our waterproof chambers. We give them a 5-year warranty, which is unheard of in the industry. And we also have the ability to, like I said, use any of the different ion chambers and diodes and scintillation detectors we use. You can use pretty much any type of detector on the market with our system. Easy serviceability, all the main components, the motors, the control unit, the cabling, the power supplies, the electrometer are all user replaceable components. So it's something that you don't have to replace the whole unit. You can just replace those component parts very easily. The motors are fully interchangeable and self-aligning, so they kind of set themselves up when you take 4 screws and replace them, just in case something happens to a motor down the road. It's rare, but it has happened, and we're not going to shy away from the fact that sometimes repairs need to be made, but when they need to be made, ours are very easy to do. And the lift card and the Phantom, they both use interchangeable power supplies as well. So the software now, basically, we reinvented and rebuilt and rewrote our software about 2 years ago. From the ground up, and the new software is, we like to see it as possibly the easiest and most intuitive to use. It's an easy left to right, top to bottom navigation like you're used to with any kind of Windows interface. We don't have any hidden features. Everything is basically at your fingertips for the viewing and for the analysis and the setup of your scans. We have very intuitive menus for scan queue setup, for measurement and analysis, and those are just 3 tabs basically on the splash screen here. And that being said, let's take a quick look at the software. So as I mentioned, here's your splash screen. The setup tab, very simple. As we set up your clinics and your machines specifically. So for example, here, this is a sample one. We've got a Halcyon and a TrueBeam set up there. You just give your basic information for those. You set up your detectors. In this case, showing any number of detectors we have here that you can utilize. Nice thing too is if you choose a diode or a solid state detector, little safety feature when you set those up. If you go in and you're ready to scan, you cannot turn on the bias for a diode. There's a protector on there that eliminates the ability to turn the bias on, so you won't damage any diodes or electrometers turning the bias on to a solid state detector. I'll jump into scan queues in a second. Just want to touch on the preferences real quick. This is just pretty straightforward. We offer some different delimiters for the CSV files or decimal separator. I know internationally, typically a comma is used, where in the States the period is used as a decimal separator. So you have those options as well as date and time formats too. But going back to the scan queues, we can easily add a scan queue. We like to see that, you know, compared to a lot of our competitors, we definitely have the easiest scan queue setup. It's automated and will produce those scans as the scan queues very quickly and very easily for you. You can see here the not set portion. So it kind of steps you through, and as you step through the functionality of it, these will tell you that that's completed. So for example, I'll put in a test set. I want that to be in water. I want it to be photons. I want to do MLC, no wedges. Now you can see this is marked as complete. You easily choose same way you choose your energies. I want a 6 and I want 10. My field sizes, I want to do maybe a 10 by 10, a 20 by 20. I want to add a 40 by 40, which is easy enough to do. I add those. And now you see 40 by 40 is up there and checked. Easy enough to get rid of that as well. If I don't want a 40 by 40 any longer, I can do that. And then my scan types. And this is kind of where things get interesting and pretty in-depth, allow you to set up those easy scan queues. I want to choose my cross plane. I want to choose my in plane. I want to do some depth. You'll see we added a couple of new categories here, our depths and our CAX offsets. So basically I've got those set. If I want to do diagonals, I can do that. If I want to do halves, I can do that. So you have all kinds of functionality there. But for my depths, I want to maybe want to do a 10 cm and I want to do one at 1.5 cm. And let's do 2 because I chose 10 MB as well. So I want to do those. And now you can see here I've got a total of 4 scans are set. I want to do just my 0. I don't want to do any off-axis scanning. The nice thing too here with our scan mode, jump into this real quick, we've got some functionality now that allows you to do either step or continuous, so you can choose continuous if you'd like. We can do single zones, which is one resolution all the way across, or if I want to do what we call a multiple zone, it gives you the ability to increase your resolution in the key areas, in the shoulder areas and the penumbra. So now I'm looking at 15 millimeters per second on the tails and the flat section, and then I'm going to do 5 millimeters per second in the shoulder and the penumbra region. So you have those capabilities as well, and you have that on the depths also. You can choose either a single resolution or you can choose your multiple depths as well. But now you can see that I have all these complete. I've got a total of 28 scans built without really, clicking more than a few times to build those full scan sets. So I'm just going to cancel out there because I don't want to keep that one. But that's kind of all that's done. In the scan queues, you can combine scan sets, you can copy them, you can edit them, delete them, export them, import other scan sets from another system. So if you have another DoseView somewhere else, you can import them. We can also import older legacy scans from IBA PTW water phantoms, so you can use those for analysis as well down the line. You always will have the ability to check your legacy scans. Jumping into the measure page now, you have this is again similar where you set up your hardware here. So you choose your machine. In this case, it's a TrueBeam. I choose my dose rates. So it will always remember your defaults here. In this case, 600 MU per minute for photons. Your step scans, your settling time at 3 seconds, your sample time at 3 milliseconds, sampling time of 100 milliseconds. And again, those are defaults that you can change at any time. You set up your water phantom, and this is nice too. We have it both the RS-232, which is also the wireless, but any live connection from the water phantom to the software is this one. We also have a built-in demo functionality, And that's nice. Like I said, as you pull these out, hopefully only once a year on a very rare basis, you want to just be able to kind of reacquaint yourself with the software. You can go into demo mode, and in that situation, you can actually do like you're live connected to the water phantom. But I can click on connect here. Then you need to initialize a phantom, and that'll basically physically drive the chamber carriage to the extreme X, Y, and Z position in the phantom as an initialization point, and then return back to center. Choose my detectors accordingly. If I'm using something like a diode or maybe a cobalt unit, I don't want a reference detector, you can do that. Set up your electrometer. I want to turn my bias on to 300. I want to apply it to the field and the reference. I can also zero my chamber or my electrometer from here, but I can also zero it when I go into the scan queue. I want to set my position, my cross plane, end plane, and depth positions. I can set my origin from here. I can direct it to go to origin, and this is where I do that locate beam center as well. So I turn the beam on, click on locate beam center. It'll move to the edge, detect the edge of the radiation field on the in plane and cross plane directions, and it will then give you any recommended shifts to move the chamber accordingly, and then you can reset your origin according to that locate beam center. And then the phantom orientation, that's just basically where you have your motion control box on the phantom, how that's oriented to the gantry. So it just knows the X and the Y. Typically it's in this position here. So, but that's basically it for the hardware setup. The software setup, I can go ahead and load a queue. I want to load this Technosan one, which props to them. This is our Italian distributor. I think there's a couple of them on here today. So, but I'll click on OK. That tells me I want to make sure that my dose rate settings are correct. So, and make sure that my electrometer is zeroed. I can do that from here. Zero the electrometer. I can normalize at this point as well. I want to turn my beam on and start my scanning. In this case, I just want to do a couple scans. So I'm going to do a depth scan, and I'm going to do a cross plane at Dmax. But I'll get those going. Now I'm doing my scanning, and you can see you have a green progress, the active scan, which is going right now, and then a progress percentage too for the scan. And while those are going, I'm going to run to jump into Analyze here in the interest of time, but I can load my scans here. Bring up your previous scans, and I want to do just a small sample of scans that I did back in February. So I can choose those. I want to maybe take a look at all 4 of those scans. I've got 4 profiles and 1 depth scan. And hopefully you just heard that bell. That's basically telling you that I go back to the measure page, that my scans are done. So that was just an indicator that either your scans have completed or you needed to address something. If say, for example, you had to change your field size from 10 by 10 to 20 by 20, you'd get a dialog box here telling you that that's why that bell rang. Otherwise, it's a completion bell as well. But going back to Analyze. So basically, with the Analyze the scans, you've got your profile data here. You can see, you can click on your depth, and it'll show you the depth as well. We've got any number of filters and analysis tools you have here. You've got a couple different smoothing algorithms. We've got Gaussian and Boxcar. We've got the ability to point edit. I'm sorry. So you can edit any point. You can normalize to a value. You can normalize at the center. You can center the scan itself. You can do an average symmetric calculation. You've got your mirroring. You've got your shift, and you've got your flip as well. So you've got all the conventional tools for adjustment and analysis and processing that you'd be familiar with, to use those tools to get your correct information. But then here you also have your scans. You can click on the metrics tab, and you get your flatness and your symmetry percentages and results. You can choose any number of protocols. In this case, we're using the AAPM protocol, but you can use the IEC or the Electa US, the Varian, the AERB, the flattening filter-free analysis as well. Any filters that are applied, for example, here, if I go to depth, I've got the dose convert according to TG51 is applied to this depth dose already, or this depth curve. So you've got all that good functionality there as well for your filters. And the nice thing too is that, for example, if I want to go back to my profiles, and for example, I want to maybe do a 1 cm shift. So I can always show my raw data, and then my filtered data, in this case showing that shift. If I want to clear any filters out, I can clear those filters out easily enough. I can remove the last filter. You can merge your half scans here as well. Nice thing too is you can export it to just about any number of treatment planning systems, as I had mentioned, and that includes these listed here. We've got Eclipse, we've got Monaco, we've got the Electa Aqua QA protocol, we've got Philips Pinnacle, we got Brayplan, we've got more in the works. CyberKnife is probably going to come down the road before too long as well. You can also export it in DoseView format. So if you have another PC somewhere, say your laptop or traveling laptop that you want to import those scans into, you can do it in a conventional CSV. You can export them as PDDs. And then you also have the ability to convert those PDDs to TPR. So that functionality is there as well. And then it's full. You have the ability to do reports. The reports are done and export to Excel, and will give you all your pertinent data and analysis results in a very concise report for on Excel. So that's kind of a quick run through of the software. You've got the ability to kind of zoom in on regions of the scans as well. You can always go back again, like I mentioned, to your raw data. You can always view your raw data accordingly. So that's kind of a quick overview of the software. And now I'm going to just kind of jump back into my last couple of slides here for the summaries. Excuse me. So the hardware, you can see, like I mentioned, we've redesigned the tank to be smaller and a little more compact to be able to fit in the Halcyon. It also improved the rigidity, gives you that great repeatability and accuracy, precision within 0.1 millimeter per axis. It's a very quick system setup and alignment to get you scanning quickly. The wireless functionality or wired for versatility, but it gives you some setup ease and time saving being able to do it wirelessly. We've got the fast acquisition dual channel electrometer with the independent bias, and it's a very intuitive and versatile detector alignment system. One thing I didn't mention, going back to that detector alignment system, we actually include, I think, 9 different detector holders for various, obviously for our 828 0.125 scanning chambers, but for farmer chambers or parallel plate chambers, those are all included. So you have the versatility there as well to use any type of detector you'd want. And then, as I mentioned and went through on our software, it's an easy left to right, top to bottom navigation. It's a quick queue setup, probably the easiest queue setup of any software out there for scanning, and it incorporates easy copy and editing functions as well. Like I mentioned, no hidden features. Everything is right there at your fingertips, so it makes things just that much easier to navigate through the software. You have the ability to do step or continuous scanning with the multiple zone resolution, which is a nice tool for making sure the more high gradient, low dose regions are accounted for within the scans. You've got the important functionality for your legacy scan data, like I said, your PTW or your IVA tanks or other DoseView systems. And again, straightforward post-scan processing and metrics are all at your fingertips. So that's kind of the whole overview of the system. I thank you for your time. I went about 7 minutes over, so I apologize for that. We did get started a couple minutes late, but one thing I'd like to just mention again, this is kind of a quick overview, but if you wanted to take a look at the system more in depth, feel free to contact your regional rep or your distributor. If you look on our website, down on the front page on the lower left corner, there's actually a link for a find your rep. So you can just enter in your location and it will bring up your representative's contact information for you to get a little more information. Or you can contact just sales@standardimaging.com or myself, H. Petersen @standardimaging.com. But other than that, I'll take a look. I'm not sure if we have any questions, but I'll see what we've got. Let's see. I'll open up the questions. Okay. How do you specify the chamber offset for a depth dose? So basically, when you enter in your chamber data within the original setup page, you actually enter in your chamber diameter, your inner diameter of the chamber, and that will be incorporated into the depth measurements when if you have to do a drop down. That's accounted for. Or you can actually add that in manually at that time as well. So hopefully that answered that question. Any other questions? Can you show me the report sections? So basically what I could do probably, let's see, as far as the reports go, I can probably, if it's okay, John, it's like I said, it's a Excel spreadsheet. I can send you a sample of a report if that's okay. Let's see, is it licensed per PC? It's not licensed per PC. Basically, it's licensed with the tank because obviously you need the hardware to run the software, so you can actually put the software on any number of PCs. So you have that capability. And as far as results of reproducibility to a long time, the system itself has been out for a number of years, and I don't know if we've done actually a test on that, but when we develop the tanks, we run them, basically hours on end and hours on end, and our test tanks are really given a thorough run through as far as both development and before they go out the door. So the reproducibility does maintain. I can probably either, if you want to email me, I can get you in touch with our lead engineer on that and give you a little bit of a more information on how the testing process is done. So as far as in the depth dose measurement, what is treated as a 0 point? Basically, that's up to you as far as how you want to set that. You can set that accordingly. There's some versatility there. So as far as the 0 point goes, you can certainly set that as you see fit. Considering the wireless communication with Zigbee, what do you provide to have wireless communication at the console with the PC at the console? So basically, you do need to have um, you run a cable into the room, and then from the wall to the system, there is that's the wireless component. So there will still need to be the radiation. Um, you need the radio transmitter and receiver. The receiver one sits at the wall connected to the cable that goes through the conduit, and then wirelessly connects to the motion control unit on the water phantom itself. Are there any other questions? All right, there's no other questions. I thank you all very much for your time. And like I said, please feel free if you want a more in-depth if you want more in-depth information on it, or a demo, more direct demo for question and answers directly, feel free to contact either sales at Standard Imaging or your regional rep or distributor. Thank you very much. Oh, sorry, I did get one other question. Dynamic wedge measurement. Yes, it certainly does. When the wedge measurements are set up in the setup, when you choose your different functionalities, whether you want MLC and what have you. You also choose if you want wedges, so that functionality is there as well. Again, I thank you all very much, and have a good rest of your day or a good evening, depending on where you're located. And stay safe out there.